Here's a video of the translation circuit that takes a signal from the ignition coil on an SV650 and translates it into something that the tachometer of a Gen 2 650 can read. Currently I have it's a PNP transistor installed, and the emitter, it has a little blue mark on the edge, is connected up to the tach drive signal. So I'm going to start it up. You can see the tachs tracks nicely. That's with the PNP emitter connected to the tach drive. This is what the signal looks like on the oscilloscope. The coil signal is on the top, the tach drive is on the bottom. Let me go ahead and raise it up to 2 volts per division. Here's 1 volt per division. You can see that with the PNP emitter driving the tach, that signal is 1 volt per division, so it's 1.5 volts off of ground. The threshold for the tach is 2, so this circuit is just barely working. It seems to work reliably, but with different bikes may not actually trigger the tach. So that's one thing to note there. The other interesting thing is we take this transistor out. Notice it has a blue mark on top, that's the emitter, and turn it around. Don't drop it. And we put the emitter on the ground. Then you can see the circuit still works, which is pretty interesting. Back down here on the oscilloscope. Uh-oh, what happened? Oh, signal popped out. Put that back in. Okay. Color on, and there we go. Signal. The scope probe popped out. Okay. Still working. And here's what the signal looks like now. This is, let's see, PNP with emitter grounded. And again, let me pop up the gain. This is 1 volt per division. So this is actually over 2 volts. So this one is even a little bit more sketchy in terms of triggering the tach. Here's what it looks like when we rev it up. But even though it's... Oh, no. Oh. The wire popped out again. Gotta put that in there better. Put that on there. So even though that threshold is close, it still works. Now I'm going to take out the PNP transistor and put in an NPN. This is with the emitter again. Is marked in red. So I'm going to connect the emitter of the NPN to the tach drive. And that works and tracks well also. Down here on the signal, doesn't look too bad. If I go off ground, let me zero that. Zero it, okay. You can see actually it's pretty darn good. The output is right on ground, doesn't seem to have any EMI artifacts on it. And the high level is 4.7. Now if we take this NPN and flip it around, now with the emitter to ground, you can see that tach doesn't work. And if you look at the scope, signal is just grounded. Now that's expected because the signal into the base of that transistor doesn't make it all the way down to ground. So there's a fix for that by taking a diode. We put the diode in the emitter leg. That raises the transistor up and allows that high base signal to still trigger. So that's with the diode in. And now we take a look. Okay, that works. NPN transistor, emitter to diode to ground. The output signal here looks nice. One thing to note is the output signal is about 0.6, 0.7 volts off ground because the emitter, the diode in the emitter is raising everything up. The trigger threshold low for the tach is about 2 volts, or as we just saw, maybe it's 2.2 because it was still working with that other configuration. But it's still low enough to trigger properly. So one more thing I want to show before I finish this. Here's the pull-up resistor. If we put the pull-up resistor on the collector, this is what it looks like. A real tall, clean signal. Let me turn the gain down. You can see, let me zero it again. So with the NPN, with the diode and the emitter, it comes down a little bit off ground. With the pull-up, you get a nice clean signal. This is 5 volts per division, so it's 5, 10, just about 15. And there are no glitches on that signal at all. That looks pretty good. And I hope you enjoyed the video.